0. In the center point, the resistor value will high. But when slider is moving in this portion, this low value resistance will become in parallel to this high value resistor. So both resistors will work in parallel. It is non-linear behavior of this potentiometer. This is a potentiometer. In this potentiometer, there is a resistive block, slider arm. Point A, point B, wiper. Normally we apply some voltage here, ground here, and we take taped voltage from this slider block. It will linear move from here to here or here to here. It will divide the resistor between these 2 points and these 2 points. So this linear voltage divider. Now we will make it non-linear. This is internal structure of this potentiometer. A, B, wiper. When this arm is here, it is moving on this track. If we jumper point A to point B, we connected A and B together. This time the resistive block is divided into 2 portions. Resistor right, resistor left. It is 50K potentiometer. .5 physical value. Suppose this wiper is at center. 47.54 divided by 2, 23.77. In this case, total resistance R left, R right, R left plus R right. 0.7 plus 23.7. RT total resistance will 11.85. When the wiper is in midpoint in the center, but when it will change to left side, the resistance between the outer points, 2 points, now we have 1 point here and this point is jumpered here. Its resistance will vary from 0 to 11.85. When it will reach here in the center, then again it will start to decrease. Only in center point the resistor will in peak. This configuration is not commonly used. It is used in fade controls. Counterclockwise 0, .35. Now the resistance is again decreasing, 0. In the center point, the resistor value will high. Here in the midpoint, in the center, the value is maximum. But when slider is moving in this portion, this resistance, this low value resistance will become in parallel to this high value resistor. So both resistors will work in parallel. It is non-linear behavior of this potentiometer. Thanks for watching.